Magnetism lesson number 8. Question is, what are we actually going to do with all this stuff? So let's try to invent a few things. So what I'm going to do is make a loop of wire. So if we look here, this is actually a loop of wire. And we can connect this to a battery down below. Positive end and then negative end here, say positive and negative. The electricity flows out of the battery, around the wire, comes back to the low side, and then flows back into the battery. Now here I'm going to put a little pivot, so when this thing actually starts to move, it doesn't fall off and hit the ground. So basically all that is some kind of thing to keep it from falling over. All right, now let's take a look at the forces here. All right, and if I were to take a magnet and put a north pole on this side and a south pole over here on this side, an interesting thing starts to happen when the wire goes through here. All right, now we know that the field lines go from north pole to south pole. So if I look here, I'm going to draw some B lines as they go across from north pole to south pole like so. And these are my B lines like so. All right, now when the current starts to flow up through the wire, notice when it flows in this direction that the current flow is parallel to the wire. Well, we all know that there is no magnetic force when it's parallel. It has to be perpendicular. So there are no forces here. So at the bottom of the wire, because it's parallel to the magnetic field, there is no force here due to that wire. Now, let's watch the current as it goes up in this direction. So as the current flows this way, yes, indeedy doodles, it's crossed in the magnetic field lines. So the velocity and the current flow are actually going in this direction. All right, let me check out the forces. Yes, right-hand rule number 1. Notice how my hand is completely flat. For forces, we use right-hand rule number 1. My fingertips must be for the field lines. My thumb is for the velocity. So let me take my hand and orient it properly. I take my fingers so they match up to the red lines, the field lines. My thumb is the direction of the current flow or the velocity. What direction is the force? And the answer is inward towards the board, into Miss Rubin's room. So the force here is actually directed inward towards Miss Rubin's room, pushing inward like so. Very difficult for me to draw because the force is actually going into the board itself. All right, now let's take a look at the current flow on the top. Notice here, everywhere across the top, it's parallel with the field. No forces are present because it's parallel. So on the top section, there are no forces. All right, coming down this way, there's a current flow this way. Let me take my fingers. I orient them so that they're pointed this way. My thumb is the direction of the current flow downward. The force is out of my palm towards you. Very difficult for me to draw once again. The forces here are actually headed out towards you in the direction of the back wall of the room. Remember, there's no forces on the bottom, no forces on the top. This one is pushing in, this one is pulling out. This thing is going to start to rotate. It's going to start to spin as this one pushes in and this one comes out. This is known as an electric motor. And we use this device to power many, many things that make our life easier. This is the principle of an electric motor using right-hand rule.